Good morning. Our group today will present the usage of IBS technology in the construction of the Petronas Twin Towers. Industrialized building system is a construction technique where components are manufactured in a controlled factory environment. Then, they were transported and assembled into structure on site. Industrialized building system has become increasingly important in the modern construction industry because it improves the construction efficiency, quality control, and sustainability through the use of prefabricated and standardized building components. In Malaysia, the government has continuously encouraged the implementation of IBS as a part of sustainable construction initiative to reduce construction waste, shorten project duration, and improve site safety. One of the best example of IBS application can be seen in the Petronas Twin Towers. Completed in 1998, the towers demonstrate advanced construction techniques and innovative engineering solutions. The project utilized high-strength reinforced concrete together with systematic construction process to achieve faster and more efficient construction. The use of IBS in this mega project also helped improve productivity, construction quality, and overall project management. Moving on to the project background, the Petronas Twin Towers are among the best and iconic architectural landmarks in the world. Standing at 451.9 meters with 88 stories, the towers were designed by architect Cesar Pelli to reflect Malaysia's national ambitions and modern development. From 1998 until 2003, they were recognized as the tallest building in the world. In addition, the towers symbolize Malaysia's Vision 2020 and represent the nation's economic growth and global image. Constructed over 6 years at a cost exceeding RM 6 billion, the project became an important benchmark for the successful and implementation of IBS technology in large-scale construction projects in Malaysia.
The IBS components used in the construction of the Petronas Twin Towers. First, the project applied a steel framing system for floor construction using IBS components like steel beams, trusses, decking, and reinforcement. High-strength reinforced concrete was used for the core and columns to improve structural strength and efficiency. Next, precast concrete elements such as slabs and wall panels were produced off-site. High-strength fly ash concrete was also used to reduce structural weight, level, and construction time while improving sustainability. In addition, prefabricated major components were implemented in the construction of the 58.4-meter sky bridge. The sky bridge was assembled in 5 sections and lifted into position, which improved safety, accuracy, and reduced high-altitude work. Lastly, the Pinnacle design used modular stainless steel units that function as both the exterior skin and structural frame. This reduced maintenance requirements and improved durability. Overall, IBS technology will help improve construction speed, cost efficiency, and structural performance. Furthermore, I will explain the IBS construction method used in the Petronas Twin Towers. First, the foundation works involve deep excavation of about 30 meters with 104 board posts and a concrete mat foundation to ensure long-term structural stability. Next, the core and structural systems use the automatic climbing system, which is a hydraulically operated formwork that improves safety and speed up construction. For floor construction, prefabricated steel beams and metal decking were installed floor by floor, reducing temporary supports and accelerating progress. The sky bridge installation involved a 58.4-meter bridge prefabricated off-site in South Korea, then lifted to level 41 and 42 using hydraulic systems. Its sliding connection allowed movement during strong winds. Lastly, the facade and pinnacle use prefabricated curtain wall systems and modular pinnacles, improving durability while reducing maintenance. Overall, IBS made construction faster, safer, and more efficient.
Moving on, the construction of the Petronas Twin Towers utilized a hybrid structural system that integrated high-strength reinforced concrete with prefabricated steelwork. A slip-form system was implemented for the central core and 16 perimeter of columns, which allowed for continuous vertical progress and high structural stability. To accelerate the schedule, prefabricated steel beams were used for the floor system, significantly reducing the need for on-site formwork. For lateral stability, concrete outriggers were installed between levels 38 and 40 to increase the overall stiffness of the towers. The process concluded with the installation of the steel pinnacles, which were hoisted in segments using specialized crane. Next, the project efficiency was driven by the use of major IBS components, such as the unitized curtain wall system. Over 33,000 factory-made panels were anchored directly to the floor slab via cranes, eliminating the need for external scaffolding and achieving an installation rate of 1 floor every 4 days. Another major achievement was the skybridge installation. The 450-ton structure was prefabricated at ground level to minimize high-altitude risk and then lifted into position using a hydraulic strand jack system. In terms of logistics, the limited space at the Jalan Ampang site required a just-in-time delivery strategy. This ensured that prefabricated components were delivered only when needed, maintaining a continuous construction workflow despite the site constraints.
I will be presenting the cost and sustainability of using IBS. Firstly, speed and efficiency. By using advanced jump form system, the team can complete one floor every 4 to 7 days. And these innovative methods significantly reduce the total time needed to finish the project. Secondly, labor and cost saving. Industrialized techniques reduce the need for low-skilled workers for up to 50%. This approach reduced site-related costs by roughly 14%, keeping help the 1.6 billion project within budget. Thirdly, precision and organization. Messing components such as glass and steel as your walls were built off-site to ensure high precision and quality. This method created a cleaner, safer, and more organized construction environment. And lastly, sustainability and waste reduction. Precisely manufactured parts meant for less material was wasted compared to traditional construction. Instead of using disposable wood scaffolding, the team used reusable item, steel forms, saving natural resources and following modern environment standards.
Next, I'll explain the advantages and challenges of using the Industrialized Building System or IBS in the construction of the Petronas Twin Towers. Firstly, one of the main advantages is time efficiency. The use of about 4,000 tons of structural decking reduced the floor cycle time from 12 days to only 4 days. This shows that IBS can significantly speed up the construction process. Besides that, IBS also helps to improve the quality of construction. Many components such as curtain wall system and pinnacles were prefabricated in a controlled environment. This ensures better accuracy and reduced defects compared to traditional methods. Another advantage is better safety during construction. The use of hydraulic self-climbing foam will reduce the need of workers to carry out dangerous tasks at high levels, which help to lower the risk of accident. In addition, IBS reduced the needs of a large number of workers on site. This not only improves site management but also reduces material waste, making the construction process more efficient and environment friendly. However, there are also some challenges when using IBS. One of the main challenges is high initial cost. The use of advanced technology and specialized equipment requires a large amount of investment at the beginning. Another challenge is related to transportation and logistics. Large components like the sky bridge are difficult to transport and install, and this requires careful planning and heavy machinery. IBS also depends heavily on skilled workers. If there is lack of experience or technical knowledge, it may cause delays in the project. Lastly, due to the unique design of Petronas Twin Towers, many components could not be standardized. This increased the cost and makes the process less flexible. Overall, IBS provides many benefits in terms of speed, quality, and safety, but it also requires proper planning, cost control, and skilled workers to be successfully implemented.
In conclusion, the construction of the Petronas Twin Towers clearly demonstrates how effective the Industrialized Building System, or IBS, can be in large-scale construction projects. Through the use of prefabricated components, high-strength reinforced concrete, steel framing systems, and advanced technologies such as the automatic climbing system, the project achieved higher efficiency, improved quality, and has a smoother construction process. In addition, IBS helped to shorten the construction period, reduce dependency on manpower, minimize material wastage, and promote sustainability through the use of durable and recyclable materials. Although there were several challenges, including high costs, transportation difficulties, and the need for skilled labor, the overall benefits of IBS were much greater than its disadvantages. Today, the Petronas Twin Towers stand not only as an iconic landmark of Malaysia, but also as an important benchmark for future IBS application in the country. Overall, IBS technology has proven to be highly effective and beneficial in modern construction projects. That is all from us. Thank you.